Good evening. Hi, I'm back. My name is Lungile. Some of you might know me by now, but my username is Tintsalo, as renamed by my daughter, which I've decided to leave because it's got sentimental value. So I'm back yet again. Where I am, it's quarter past 6 on the 13th of July, and I'd like to present an update, which is gonna be our version 1, which will be available for students, graduates, um, young consultants for the exchange for the heat exchanger design. So it's meant to be a verification tool that one can use to confirm that they're moving in the right direction in their design. So this is version 1, which I would really like to get feedback on. So if you do need a spreadsheet like this, please do contact me. Let's discuss so that you can start giving me feedback. The session I'm doing today is actually to try and break the spreadsheet. So I found a design example on DWSIM. So what I want to do now is I want to try it live and see if the spreadsheet will give me sensible results. So tag along. Hope you enjoy the show. So let's get started. First thing I did was I found a nice example on DWSIM. So it has gasoline coming in at 377 Kelvin. It's in liquid, and then it's going out as 312 Kelvin, and it's still a liquid. And then you're cooling it down using cooling water, which is at 304 Kelvin, which comes out at 311 Kelvin. So it's a liquid exchanger. You can see that this is an example. Even the units that they used here are English units, so they're not standard units that we use, your SI units, but I've changed that. But we're not going to focus on the simulation today. If you want to learn more on DWSIM, please do give me a call. I would love to share what I've learned so far. It's such a beautiful tool to use. Yes, like any simulator, there are times where you'll hit some snags, but what I've found with DWSIM is that it's so accurate that should you try to design an exchanger and not account, for example, for the fact that there's condensation, right? The spreadsheet, the simulator will tell you. You will see that the results do not make sense, and you have to go back and fix it. So it becomes easier for you to interact with the simulator and get the information that you need. All right, so I'm not going to do much here. I've already updated my units, so I'm immediately gonna go to the material stream. I'm gonna refresh that, and I'm gonna copy that as it is. Right, copy to clipboard. Now, when we come to our spreadsheet, you'll see currently there is nothing. So I just wanna make sure that my I'm gonna paste on A1, which is the first stream. But before I paste anything, I just like to show you that everything is currently empty. Left it as it was. And what we'll do now is, as you can see, your design report shouldn't have anything on it. So if you check your design report, you'll see that some of the things are still saying NA. So we're gonna go back now and paste our raw data, right? So you paste your raw data, A1, and then make sure that it populates correctly. Stream 2 should have type, and then it will have feed, product, right? And then the rest is automatically sized to make sure that it picks up the correct input. Confirm that your flows are right, because the flows are critical. Your flows are basically what I've done with the sum of the search items is that because flow is fixed, right? In is equals to out. Some of the lookups check the flow and use that as a reference. Right, so we're going to go in now. You'll see it's updated. So the first thing we need to update here is the fact that it's liquid to liquid, right? And then for now, I'm gonna say leave the hot stream on the tube side. So let's start by selecting an outer diameter. For this example, I'd like to start with 38. So 38, standard wall thickness is 2.1, 2.8, 3.4. So maybe let's type 3.4 just to see what happens, right? and then everything else will auto update here, so you don't need to do anything here. So anything that is not in orange mainly means you don't have to update. For example, here you can select what method you want to use. So we've got the Kern method or Bell Delaware. For now, we're going to stick with the Kern method. Okay, then here you can decide whether you want to automatically, right, select your shell side fouling and your tube side fouling, or you want to use the database. But the one thing that you need to do is you need to specify what is sitting where. So here we said on the tube side we want the hot stream, and the hot stream we know is what? We know it's the fuel. So let's see what options we have. We have heavy fuel, we have fuel oil, so I'm gonna go with fuel oil. That shouldn't have happened. Let me see why it's not allowing me to select. That shouldn't have happened. But anyways, the whole point of this session is to see the whole point of this session is to see where my simulation or where my spreadsheet has errors. So it's a good thing I picked that up, and it's something that I will need to change. So the reason why some of these cells are protected is to make sure that you as the user do not end up making mistakes and doing something that you cannot undo. Whereas I will always have a master copy, so whenever you make a mistake, I will be able to go back and check. But to avoid the back and forth, this is an addition that I've made. So I've updated to fuel oil, and it will update on the calculation as well. As I said, on the orange is where you update, and then whatever you see as gray, you do not touch anything there. It's calculated and shouldn't be updated manually. Okay, so now we proceed. Then we're gonna come to your estimated U value. You'll see on the hot fluid it says gasoline, cold fluid it says water. And then here what I'll do is I'll just select a value, an estimate value for my U estimate overall coefficient, right? And it comes to 49.7, which is rather small. And one of the problems that you'll see is that your number of tubes now will be high, right? So on auto, so your number of tubes also is on auto calculate, so it gives you 21,000 cubes and 8 tube passes, and then your shell diameter is 5,400, right? Which is quite big. This is quite big. This is like 5 meters, right? Of a 5 meters in terms of your shell diameter, which is huge. So what can you do to fix it? All right, let's start by something obvious. Let's start by maybe choosing a smaller outer diameter on your tubes. So we're going to go 16, and then this one is meshed with 1.7 in terms of your. So now let's see what this comes to now. It's even worse, it goes to 23,000, but at least your bundle diameter is much better, right? So you can either go with that, but we can try again our U estimate and see what that gives us. So let's start with an estimate of 1,250. That comes to 106, which is not bad, right? But still, we don't want to be dealing with very large areas. So if we can now go and check your total areas. So as I said, your bundle diameter will be now 2.4 meters, which is, in some cases, I mean, I had a discussion with a potential client who said, they work with large heat exchangers, but I'd like to go smaller. So the question is now, what do you do about it when you are at this stage? The other thing you want to check is you want to check if everything makes sense. So what you can then do is go to your results dashboard, and what I usually do is I come here. So here is where it gives you your design limits, right? So in terms of velocity through the tubes is okay. You're looking at about 1.83, which is within design margin. Reynolds number should be greater than 2,100. You're still okay. But two issues arise here. Your number of tubes and your shell diameter are too big. So what can we do to immediately fix this? All right, so let's go back. What if we swap around what sits in the tubes and what sits in the shell? So instead of having the hot stream in the shell, I'm going to put the cold stream in the shell. So what happens if I make that swap, right? So now I'll come back. This is the first place where I update. So I'm going to start with 1250. Now that is much better. Immediately you'll see that my number of tubes now makes sense. They are much lower, right? So now what I'll then do is I'll then come to my buttons, and I'll run an optimization on this to make sure that everything else is updated. So immediately when I've done that, I can come back to my design report, and you'll see that everything is now green. Everything is good to go. So which means that everything in terms of your design is within margin. Then you can go back and check. You can check your area margin is within spec. You can go back and check that if the spreadsheet has converged. Yes, it has converged. So which means everything is okay and you are ready to produce a design report, right? So next what you'll do is you'll go generate technical report. So what it will then do is it will then give you your design report, heat exchanger, and a general drawing. So I'm going to do that now. Generate technical report. Okay, so let's go in and check how our technical report looks like. Excuse me. So I'm going to go to today's lecture, just to put it up on the screen. Heat exchanger design. So today's class, I should look for the technical report for today, which is this one at 1825. Let's open that. And we have our technical report. So what you'll see, it will give you a tube pitch, it will give you a number of tube passes, it will give you the number of tubes. If you go down, you'll also get the drawing. So that's what you'll get as an output from the exchanger. It should also give you the heat transfer area required, which would be 1.9 meters squared, and then available. So now you can get to a point where after you've done your design, you can check. I didn't change the material of construction, but you can also update that. If I can come back and show you in terms of material of construction here. So here you can choose. So let's just say that your particular client said they want aluminum, for example, right? Once you update that, again, I need to deal with this issue. So you can update that to titanium, for example, and then you'll see automatically it will change your thermal conductivity, your tube thermal conductivity. To double check if everything is still okay, just choose a value, and it will iteratively come to the converged new estimate, which means you can create a new design report. It should have slightly different values. Then you just make sure that everything makes sense. All right, so that is the updated version of the heat exchanger simulation. As I said, I would like to see people trying it out. Please do contact me, and I would really love for you to try it and use it in your workplace or use it for your design project. Thank you very much. I look forward to talking to everyone who will be interested to give me a call. Cheers. Bye bye.